Everyone and welcome back to PostNetwork Academy. My name is Bindeshwar and I am thrilled to guide you through today's lecture. So today we are diving into a fascinating and essential topic, the relationship between moments calculated about the mean and moments about an arbitrary point. For more resources, you can visit website, YouTube channel, Facebook page and LinkedIn page. So moments, as I have explained in the last video, play a pivotal role in understanding data from measuring dispersion to detecting asymmetry and identifying key trends. You might be wondering why this session is important. Moments help us decode the underlying patterns in data. The mean serves as a natural reference point, but in many practical scenarios, such as comparing data sets or analyzing shifts in distribution, we need to compute moments about different reference points. So here just we will find relationship between moments about mean and arbitrary point. So moment about mean, mu r is expressed as 1 upon n, I is equal to 1 to n fi xi minus x bar, where x bar is the mean of observations, raise r, where r is from 0 to 1, 2, 3 and so on. Now the same expression you can write like you will subtract a from xi minus x bar and you will add a. So there would not any change in the value of the expression. Now equation 1 I have written is, now see that if we take di, where di is the deviations from each observation from the point A, so you will get, if you multiply it by fi frequencies and sum from 1 to n, so see that finally you will get fi di upon n, where fi di sums from 1 to n, that would be equal to mu1 dash, where mu prime or mu1 dash is first order moment about an arbitrary point. So I can write mu prime 1 is equal to x bar minus a, and di we already know, di is equal to xi bar minus a, and mu prime 1 is equal to xi bar minus a, and we will plug these values in equation 1. So we will get mu r is equal to 1 upon n summation from I is equal to 1 to n fi di minus mu prime 1 raise r. Now we found this relation and we will use binomial theorem. So if we use binomial theorem, so we will express di minus mu prime 1 raise r using binomial theorem, where c rk are the coefficient in the expansion, where c rk denotes if there are r elements or objects and we are taking k at a time, so that would be the expression for that one, that is called combination. We will see in the separate video. And if we distribute summation over all the term, finally we will get mu r is equal to mu dash r c r1 mu prime 1 mu prime r minus 1 plus, and these expressions we will get. Now if we put r is equal to 2, so we will get mu 2 is equal to mu 2 prime minus mu 1 prime square. If we put r is equal to 3, so we will get mu 3 prime minus 3 mu 1 prime mu2 prime minus plus 2 mu1 cube. And if you put 4, so you can see the expression mu prime 4 and other parts. See that these expressions are very important to calculate skewness and kurtosis. In already mu2 is variance. So the you can say that mu2, mu3, mu4. These expressions in terms of an arbitrary point are very important. Mu2 is second moment about mean, mu3 is third moment about mean, mu4 is the fourth moment about mean, and mu dash are moments about an arbitrary point A. So in future video we will see that how Pearson's coefficient are defined using these expressions, and we will also calculate skewness and kurtosis. So hope you understood. If you have found this video useful, subscribe YouTube channel, follow Facebook page and LinkedIn page. You can also visit website. So see you in the next video.